Welcome to S.O.I.L. Today we're going to talk about a new revamped way to work and look at soil. And as you can tell, I'm so happy to be recording this video for who knows how many times from the other videos. So what is S.O.I.L? S-O-I-L as acronym. S-O-I-L stands for soil, structure, or substrate. Okay, any of those, right? So let's go with structure for now. Structure, osmosis, ionization, and lattice. So structure slash soil slash substrate, it's, do you have clay? Do you have cocoa core? What do you have in it for aeration? Okay, what's the substrate itself, right? The structure of it, right? Is it porous? Is it viscous? Is it airy? Is it loamy? Can you touch it? Can your hands go on it and grab it like that? Or when you try to grab it, right, does it say no? That's what structure is, right? Or soil or substrate, all right? Let's move on to osmosis. Osmosis is defined by a root's turgor and its interaction with the environment, which goes on to ionization, all right? Turgor, I'm not a biologist, okay? Turgor has to do with a root's ability to draw in water, store it, and to create an electrochemical gradient, is the easiest way to put it, right? Positive and negative, right? To keep water inside of it or pushed out of it, right? Whether it needs water in it or out of it. Okay, there's different levels to the zone of the root zone itself, but I'm gonna have to look more into that, right? Like you have the root zone, the outer root zone, and then how it connects to the soil itself, right? A lot of people don't look at it as a massive structure, and while that might seem simple and obvious, right, it's actually tied into deeper things. So osmosis, water has to do with water, plants taking in water, okay, and also outputting water through transpiration, I do believe. So the osmosis part has to do with how does the structure of the soil take in the water and how does it affect the root turgor. If it's good enough, right, and there's enough ionization, right, and the structure is good, the turgor of the root should be in healthy and optimal condition, and this should allow it to take in nutrients as well as protect itself from any viruses, all right? And this should affect greenery, leaves, stuff like that, all right? Osmosis goes hand in hand with ionization. Osmosis has to do with water, all right? When you water it, because water in a sense is charged, and I think it's diamagnetic or one of those properties, right? Everything has a purpose, right? Everything has a scientific meaning too, right? The more you study, the more you know. It's pretty interesting, all right? So ionization, all right? Ionization stands for electricity. When you water, whenever there's a storm overhead, electroculture is real. Whenever you put a wire in the ground, whenever you put toss a penny, whatever floats your boat, right? It could be anything small, anything big, right? Magnets don't count because that has to do with magnetoculture, right? That's different. But ionization, when you water something, right, how does the water flow throughout the structure and how do the plants process osmosis through the turgor? Because nutrients, NPK, ionization, I'm relating it to NPK, okay? NPK, if you have a good osmosis and structure, right, you should be able to have a high ionization, which has to do with how water and nutrients flow. Think of it like this. Your body has bioavailability, right? Like, take an example of fenugreek seeds and ashwagandha. This will make testosterone and other chemicals inside the body more bioavailable to be used. Because you can have a shitload of testosterone and all it does is piss you off and it doesn't actually help repair your body, okay? So I'm using that as an example, right? So you can have a high NPK and what ends up happening is you're burning the soil and you're burning the roots, right? That should not be happening in an optimal soil, and at the same time, you shouldn't be burning the soil, like in general. You get me? Don't over fertilize, right? But at the same time, a good soil should be able to tolerate a lot of fertilization. So ionization, how does the electricity, the electrochemical structure, and the microbiology, and how is it affected by ionization, ions? This is what's called the cation exchange capacity, right? Or cation exchange rate. And what this is cations, if I remember correctly, has to do with ions and how ions take nutrients and they bring them to the roots of plants or to the soil as a microbiome, okay? Cation exchange rate, you could think of it as basically the soil's version of the electricity in a house, right? It exchanges electricity, right? Without any electricity, there's no power. Without any power, the growth can't really start, even if there's everything inside the house. And in that case, metaphorically speaking, the house is the soil, all right? So that's ionization. It has to do with cation exchange, and it has to do with nutrients. Like, now let's go on to lattice, all right? Soil osmosis ionization lattice, okay? This is to replace NPK, but NPK is also indirectly involved in it, alright? Because you have to bring it together, because there's not really a good structure. Because permaculture seems to not be related to polyculture, and it's not related to greening the desert, and it's not related to gardening, and it's not related to botany. I realize that a lot of seemingly a lot of the, you put it like this, if everyone in the world grew a garden, do you think there would still be world hunger? That's a very complex question and it doesn't have a simple answer, so don't say yes or no and don't come and attack me later for that, okay? But people don't have developed enough culture when it, what's the term for it? Culture would be like a sub-term for it, right? But let's say culture. They don't have a developed enough culture when it comes to fertilization, handling soil and stuff like that. You have people in Africa working with bare minimum, right? They don't even have anything to work with, even information, and they're growing entire forests, right? We're doing something wrong. And let's take a desert, for example, with ionization and osmosis, okay? Again, I'm not an expert. I could be getting some of these wrong or mixed up, all right, or reversed. So a desert, you're greening the desert, you're making swales, right? Which basically in a desert, you dig, you make elevation changes so the sun hits it at different angles and the water evaporates differently and it stores it differently, right? It has to do with, oddly enough, thermodynamics, the thermovoltaic effect, in the desert, piezoelectricity likely, and a whole bunch of other stuff, right? But when you're greening the desert in this sense, the sun hits down on the soil and that creates a lot of electricity indirectly, ionization. So if you figure out a way to supply fertilization or active water to allow the soil to grow naturally without having to supply fertilizer, right? Then the desert could naturally bloom without having to focus on, I gotta bring the soil, I gotta fertilize it, I gotta keep it consistent and do all of that. No, instead, lattice would build around the principle of permaculture, polyculture, and creating something that's probable and permanent, okay? Something that doesn't need constant maintenance and will scale up exponentially, if not logarithmically, with the benefits for when you do fertilize it, instead of having to keep it consistent and having a linear effect, right? A flat line of effects, right? Just to keep it stable. It should be able to grow higher and it should have polyculture-like effects, being able to help the environment and protect the environment. Go back to osmosis, which in a sense ties into ionization, both together in a protective sense, defensive form, outside of just growth. This helps the plant protect itself against diseases and plants. And I have no idea about the other stuff, like, I'm gonna edit this out of YouTube, like say heavy metals and the more conspiracy-like things, okay? But it helps protect the plants, alright? Because when you use nutrients a lot, you have a lot of salt, okay? Good example is if you put ash in the soil, too much ashes, right, could increase the salt crap ton. I have a device that has two electrodes. You stick it in the ground and it measures the salt capacity, right, and it measures its fertility based on that. It's pretty handy, very handy actually. You can have a perfectly looking soil, right, and it's dead, or you can have a clay soil, right, and it's nutrient rich. This is where I learned, right, that clay soils, they hold a lot of nutrients, but they cook out very quickly, right. You have to learn to maintain clay soil. Every soil has its own thing. Soil, S-O-I-L, is meant to replace that. So let's go over it again, if I can, alright? Soil and structure goes over with the type of soil you're using, alright? Like I was just referencing clay, cocoa core, yeah, it doesn't have perlite, vermiculite, right? What's the term for it? Amendments, what soil amendments does the structure of it have, right? Is it clay? Okay. If it's clay, how does it store nutrients? You have to look at the composite of the thing you're working with, alright? If it's cocoa core, it doesn't store nutrients that well, right? And actually cocoa core can degrade if you don't handle it properly when fertilizing, okay? Alright? Does it have, let's move on to say ionization and osmosis, right? You're working in the desert, okay? Do you have biochar? Biochar is very critical, right? It doesn't matter, it doesn't have to be from softwood, okay? It just has to be biochar from decent quality wood that doesn't have a ton of sap in it, okay? You burn it out, alright? You put it in the furnace, right? You don't have to create a pyrolysis plant, right? You toss it in the furnace, you put it until it's scorching hot, right? Scorching hot, right? The wood itself, okay? And when the wood is red hot, you quench it like a sword, okay? And that, you have biochar. Shiny, pretty cool, right? They recommend using a certain types of woods with it, right? But I never realized this, and I've been using pine in my garden, And if you honestly want, I could show you my miniature garden that I put minimal effort into, and God, it looks pretty decent, right? So the point of the first matter is to create something that's sustainable and self-efficient. Okay, you don't want to be just planting a brassica farm and have to plant a brassica farm and have to plant a brassica farm, and ooh, you know, you want something that you can plant brassicas of different types, right? Not just cauliflower, okay? And to have it consistently grow, kale, have it spread, right? Because here's the thing I never got, okay? Plants will produce so many seeds. I saw a collards plant come to seed. It was as tall as this house. I saw a collards plant grow a solid 6 feet tall, and it produced around 12,000 seeds because each pod had around like 8 seeds in it, right? And there was a shitload of pods, okay? All right? So I figured, right, why is everyone struggling? So, you know, this all started with gardening, and it moved on to some more complex stuff from other of my videos you'll see, right? But let's get back on it. Osmosis, right? This is an interesting one. Water, is it activated water, right? Electrified. What nutrients does the water have? How, this is in a deeper sense, right? Like how are the nutrients affecting how the electricity is being delivered to the plant? How is it affecting the plant's turgor indirectly instead of it being absorbed, right? Like say, let's say mycorrhizae, right? And different types of mycorrhizae, tongue twister. Say it 5 times, 10 times quick, alright? So say you have mycorrhizae, alright? This benefits osmosis because mycorrhizae binds to roots, right, on a more cellular level, right? And this helps the plant absorb nutrients that it basically can't because it's the roots can only absorb up to a certain micron and within its root density, right? The first zone of its root, right? Like, you know, when you pull up roots, like say with a taproot plant, right? It could be any plant, right? And there's still dirt attached to those roots, right? That you could call that the first root zone, right? Okay, or the second, right? It depends, right? So this root zone, you want to make sure that it's healthy, because if it's not healthy, you could give it everything in the world and it ain't gonna give a shit. Okay, so osmosis, ionization. Let's go back to it. Okay, electricity. If you electrify the soil, I'm pretty sure the plants aren't gonna like it. But if you do it in a certain specific way, through water, through a storm, electroculture, right? Because the thing is ionization is a replacement in a sense for NPK, a subsidiary, right? For NPK, right? Why is it called potassium? It's nitrogen, phosphate, potassium. Interesting. You know, like stuff like that could confuse a normal person, alright? Because, you know, you have two things that represent nitrogen, phosphorus, and then you have K, which comes out of nowhere, and it doesn't stand for anything K, okay? Anyway, you have nitrogen, phosphorus, and whatever the hell else was on there, right? I'm already losing my goddamn mind. Alright, the cation exchange, right? When water is delivered to the soil, right? This is tying into an important note that I want you to take. When you water a plant in the daytime or under certain conditions, it forces it to grow because of electrical gradients in cation exchange. When there's a gradient or a massive, like let's say a massive gap, okay, between the polarity of here and there in the soil, right? Like there's a negative charge here and a positive charge here. Okay, this happens on a microscopic level, alright? During the day, this creates a heat zone on the top, cooking the soil, and a cold zone on the bottom. And, you know, this creates cation exchange, right? Nitrogen, and it builds the microbiome in a primitive way of explaining it, okay? This is ionization, it has to do with electricity. Now, lattice, how does all this together? How does the electricity benefit the osmosis? How does the ionization benefit the osmosis? How does the osmosis benefit the structure, which should be self-permeating, right, and self-improving, and it should be able to grow exponentially as you add to it? And how is it working together as a soil, as structure, osmosis, ionization, and as a lattice, okay, as a soil? Does it have a soul or does it not have a soul? You know, that's not meant to be a corny line, like I'm being dead serious. Is it alive or is it dead? Is it a substrate? Is it dirt? Or is it soil? I hope this helps. You know, this is to redefine gardening and to solve world hunger, hopefully.